Okay, so are you guys able to hear me? Just drop a yes or no in the chat. Okay, so Saurabh says yes. What about rest of the people? Are you guys able to hear me? Okay, so Savan says that I have not understand fraction 2 questions in Fang 2 class. In fact, how I don't know how I approach fractional questions. Savant, first read the merge case sorted arrays problem. Try to read that problem first. Take that problem as the base problem and then think about it. Glad to see you here as well, Naveen. Glad to see you here as well. Cool. So we are going to just start in a couple of minutes. Let me share my screen and complete the setup. Okay. Okay. So are you guys able to see the writing pad? Is everyone able to see the writing pad? Drop a yes or no in the chat. Naveen Kumar, if you will ask me, I will prefer macOS. Okay. So today's class is going to be on graph interview problems. Fair enough. Right. So this micro course is going to be on graph algorithms and graph interview problems. So what should be the main agenda? Why you should attend this course is this course will help you to get a gist of what kind of different variety of problems you can expect around graphs in interviews. This will help you to get a grip on how you can prepare for graph algorithms, so on and so forth. Right. So I guess Rohan, I guess that answers your question. Jamila, in this micro course, we won't be always taking everything on the advanced level. Definitely, we'll be taking few advanced questions, but we'll be keeping things of mix of everything. We'll be keeping few easy problems, few medium level problems, few advanced level problems. Does that make sense? Are you guys able to understand this point? Drop a yes or no in the chat. Yes, Naveen, I'll be focusing more on English. Don't worry. Cool. So, guys, we are just going to start in about 5 6 minutes. Let's just wait for more people to join. Till then, I'll be completing the setup. If you have any doubts in your mind regarding the micro course, do ask me. Uh, no, Sayanta Paul, I don't think so. Uh, have I missed any of your doubt? No, I guess. Yes. So this class is also going to be of 2 hours. Rohan, in the interviews which aim for which are mainly focused on the hiring of software development engineers, right? Basically SD1 and SD2, I would say. Same here, Santa. I'm also very excited. Yes, Rohan, this is a computer science class. Sagar, maybe I can share at the very end. I have not curated one for you guys. Maybe I can do on the third class of the micro course. Fair enough. Definitely, Santa. I can have a Q&A session. If you guys are having any doubts, you can ask me now. We are just waiting for a few more people to join. We'll just wait for 5 minutes and then we'll start. If you have any kind of doubts, any suggestions that you want from me, any guidance that you want from me, I'll be really very happy to answer that. Right. All the people who are currently on watching on YouTube, you guys can directly join on Unacademy. So today we have Aman with us. Aman will be the teaching assistant for today's session. So Aman, can you please share today's class link on YouTube as well, so that anyone who wishes to join can directly join us on Unacademy. Guys, you will be able to give quizzes and interact live. with me here, so make sure that you do that. Naveen, I would say focus more on concepts like DS algo and design. That should work fine. Okay, so Aman has pinged the link for the class. Guys, if you will just log in, then you will be required to drop a login code. Just drop the login code as Sanket 10, and you will be able to attend the free class, right? If you are facing any issue on that part. Binu, no, but there will be some prerequisite expected for today's class. So I'll share the prerequisites so that you can judge on the fact that whether you need to understand. Definitely, Mayank, I'll share the prerequisite. Uh, Kotlamani, I would say we have already taken three sessions. One was taken by Ericto, one was taken by me, one was taken by Triveni. This weekend, Friday, Saturday, Sunday, do check out the YouTube channel and watch those videos. I guess that would help you. Yes, Santa. Uh, I will also share you few questions that were asked to me in few of my interviews. So just stay tuned on that part. Naveen, I'll tell you the prerequisites. I've not revealed the prerequisites yet. Uh, we'll just wait for 2 more minutes and then we'll start. Right. Guys, you can just directly join on Unacademy. Raghavendra, I won't say it is for absolute beginners. You are supposed to have basic knowledge of graphs, but we will definitely discuss few easy problems on graphs as well that can help you to brush up your basics. Mayank, do practice. Rohan, you can that you need to judge, I guess. Cool. Fair enough. Fair enough. Okay. So without any further delay, let's just start. Right. Let's just start. So what's the agenda of this micro course? What's the agenda of this micro course? To get a diverse uh, questions, or I guess I can say get a diverse problem solving experience of graphs. Right. This will be the main agenda, and we will be focusing on problems relevant for SDE 1 and 2. Right. SD1 and 2 hiring, this will be relevant for them. Right. What are the prerequisite? So the prerequisites are basic knowledge of graph, basic knowledge like you should be able to code a graph on your own, basic knowledge of graph. If you don't know what are graphs and how you can code it on your own, we have already taken one free live class. You can definitely check out that on Unacademy. Right. Basic knowledge of graph. Also, you need to have few basic knowledge of recursion and few data structures like queues, linked lists, etc. Basic data structure that how they work, how you can implement them, so on and so forth, and any one language of your choice. Santa, I'm not sure. This is decided by the team, so this can be a ad hoc decision sometimes. Raghavendra, sometimes if you are aiming for a higher profile of service-based companies, so let's say if you are aiming for something like power programmer profile of Infosys, then in those hirings you are asked tougher level problems. So you can expect graph-based algorithmic problems on those kind of interviews. Does that make sense? Right? Okay. So this is going to be the agenda for this whole micro course, and this is the prerequisite for today's class. Right. Okay. So guys, shall we start? Shall we start? Yes, Santa, they also ask good problems. Right. Cool. So before moving further, let me introduce myself. I'm Sanket Singh. Uh, Currently, just a second. So I'm Sanket Singh, currently working as a software development engineer at LinkedIn. Previously, I worked as a software engineer at Interview Bit as well as a product engineer at Coding Blocks. In 2019, I cracked the Google Summer of Code for Berkman Klein Center at Harvard University, where I was working on a Meteor JS based project. When I graduated from college, I had offers from various big tech giants like Sprinkler, LinkedIn, Works Application Singapore, and Dunzo, Splashlearn, Grofers, etc. I was a former research intern at the Indian Space Research Organization at the Ahmedabad Bhopal Center, which is in Gujarat. I have won few of the CodeChef long challenges with rank 1 as well as won the Infosys Digital Hackathon. Till now, I have taught more than 7,500 programmers, both offline as well as online, where I taught them data structures, algorithms, competitive programming, and fundamental of computer science. And the students taught by me are currently working in various big tech giants like Google, Amazon, SanDisk, Walmart, etc. So this was a short introduction about me. And without any further delay, let's just start today's session. Does that make sense? Shall we start, guys? Shall we start with the first problem? Drop a quick yes or no in the chat. So the first problem, I would say we will take the first problem, which will be not exactly coming from graphs, but it will be using some concepts around graph. Does that make sense? Shall we do that? Right. Okay. But few concepts around graphs will be used. And this is a very, very frequently asked questions. Few of my friends were recently were asked this problem in recent interviews. So let's say you have been given a grid of characters, right? Also, you have a word given as well, right? So what the problem says is that you will be having a grid that will be having only characters, right? You will be having a grid that will be having only characters, and you will be having a word as well along with this grid, right? Now, what you need to do with this grid and this character is find the word inside the grid, or let's just frame it like check if the word exists in the grid. Check if the word exists in the grid, right? And in the grid, we can construct the word by taking any adjacent non-diagonal cell. Are you guys able to get my point? Also, the same letter from the grid should not be used twice. Fair enough. Is this problem clear to everyone? Just drop a quick yes or no in the chat. Are you guys able to understand this problem? Right. So this is a fairly simple problem, fairly simple problem. If you will see the difficulty level would be medium, but I would say it is something like easy medium, nothing more than that. So let's say you have a grid like A, B, C, E, S, F, C, S, and A, D, E, E. And let's say you want to search for a word like A, B, C, C, E, D. You want to search this word that if this exists or not. So we can see this word exists like this inside the grid. Fair enough. So we will return a true. Is this point making sense? So if you want to construct the word from any cell, you can take any adjacent cell which is non-diagonal. Are you guys able to get my point? ठीक है चलो एक बारी हिंदी में भी एक्सप्लेन कर देता हूँ फॉर ऑल दोस पीपल हु माइट फाइंड इट डिफिकल्ट अंडरस्टैंडिंग इन इंग्लिश तो देखो यार तुम लोगों को एक ग्रिड गिवन है और कैरेक्टर्स की एक ग्रिड गिवन है, राइट? नाउ यू आर ऑल्सो गिवन अ वर्ड दैट यू आर सपोज टू सर्च इन द ग्रिड। एक वर्ड गिवन है जो ग्रिड में सर्च करना है। अब सर्च करने के लिए जब तुम वर्ड कंस्ट्रक्ट करोगे ग्रिड में, देन यू विल बी रिक्वायर्ड टू टेक एनी एडजेसेंट सेल फ्रॉम द करेंट सेल विच इज नॉन डायगनल। मतलब किसी भी सेल पे हो, मतलब ए से अगर अगला लेटर बी था, तो बी ढूंढने के लिए तुम कोई भी एडजेसेंट सेल पे जा सकते हो, but you can't take any diagonal cell, right? You can't take a diagonal cell, right? You just have to return that whether the word is present or not, and any character from the grid will not be used twice. So ये अगर search keyword है and ये grid है तो आंसर होगा true. Is this point making sense? Is this point making sense, guys? Okay, so Saurabh has asked a very good question, that anytime if you get any problems in the interview, you should definitely ask for constraints. Right. So let's say the length and the width of the grid can be as big as 2 into 10 raised to the power 2. Right. And the word can be as big as 10 raised to the power 3. Fair enough. These are the constraints that you have, and you have to solve the problem in the following constraints. Let's see who is able to crack the logic. Yes, a lot of people are on the right track. We have started with a fairly simple problem. We'll one by one increase the difficulty. We will also discuss few more easy problems, right? Yes, Savant. What about people on YouTube? Rajat, do you need any extra space for this? Like a visited array, do you require that? Mayur, you are on the right track, bro. What about rest of the people? Learner, do you need to construct it? Rajat, do you need it genuinely? Do you genuinely need it? Yes or no? Guys, think about it. Rest of the people, please think about it, how you can solve the problem. I don't think so, Savant. We'll do some good analysis in this problem, right? This is something that you should definitely know whenever you are appearing for interviews. What about rest of the people? Are you guys able to crack anything? Cool. So shall we start? Everyone, just drop a quick yes or no in the chat if we can start. क्या start करें guys? फटाफट बताओ यार. क्या डिस्कस कर सकते हैं सॉल्यूशन? काफी आसान प्रॉब्लम है, तो ज्यादा दिमाग नहीं लगाएंगे, सीधा सीधा सोचेंगे. ठीक है यार, चलो. ये कंस्ट्रेंट्स गिवन है हमें, ठीक है? इसके बेसिस पे कुछ सोचना है. We have to follow some things around it. So what we already know, what we already know is that, let's say you have a word like A B C C E D, right? And you have to search for this word, and you have to search for this word. Now what you can do, first you need to search for this starting character. Yes or no? First you need to search for the starting character that whether the starting character is present in the grid or not. Is this point making sense? If the starting character is not itself present, then it doesn't make any sense. But here you can see that the starting word was present twice. Now we have two candidates. We have two candidates from which we can start our search. Now, as soon as you have encountered an A, you need to search for B. Now, B can be present at the just adjacent cell to the right, or just adjacent cell to the down, or just adjacent cell to the left, or just adjacent cell to the up. Are you guys able to get this point? Right. If you want to search for B, A can only search for B in its adjacent cell, which is either right, left, up, or down. If we are not able to find B in any of these four cells, then can I say this A can never be the start of my search keyword? Are you guys able to get my point? Just quickly drop a yes or no in the chat. कितने लोगों को ये बात समझ में आ रही है कि यार सबसे पहले तो जाओ और ए को ढूंढो. अगर तुम्हें पहला स्टार्टिंग कैरेक्टर ही मिल गया है, लेट्स से कि तुम्हें स्टार्टिंग कैरेक्टर ही मिल गया है, तो मुझे पता है अच्छा शायद वर्ड हो सकता है. देयर इज अ पॉसिबिलिटी दैट द वर्ड कैन बी प्रेजेंट. बट मान लो if A is not even present, then definitely we can never find this word, right? So what we'll do, we'll first traverse the grid and find for all occurrences of A. Now, if we have got, let's say, two occurrences of A, then we have two candidates of cells to become the starting point of my string that I'm supposed to search. Are you guys able to get this point? That let's say I have a A here and an A here. From both this A, I have an expectation that maybe, just maybe, that the next B can be present somewhere around this A or maybe somewhere around this A. Are you guys able to get this point? So what we'll do, we have a we'll check its adjacent right, adjacent up, adjacent left, adjacent down. Fair enough? Right. Now, if we are not able to find B in any of these adjacent cells, can you say this occurrence of A is of no use to us? Are you guys able to get my point? Drop a yes or no in the chat. Are you guys able to get my point? Okay. So now here you can see that we don't know that where our next word is present. If it is present upwards, leftward, downward, rightwards. Okay, we can check for B that whether there from any of these four directions कि क्या इन चारों में से किसी भी डायरेक्शन में B पढ़ा है नहीं पढ़ा. बट मान लो B यहां भी मिल गया और B यहां भी मिल गया, अपवर्ड भी राइटवर्ड्स भी, पर हमें ये तो नहीं पता ना कि अगला C कहां पे मिलने वाला है. या तो अपवर्ड से भी मिल सकता है, राइटवर्ड से भी मिल सकता है, या दोनों से भी मिल सकता है. We don't know that where we can find the C. C can be found on the upward direction or the rightward direction or on the both of the directions. So which direction we should pick? I will say explore every direction. Are you guys able to get my point? And how you can explore every direction? By doing complete search. Or we can say we can just apply DFS starting from every position which has an A or the starting character of the given string and search upwards, rightwards, downwards, and leftwards recursively for the rest of the string. Are you guys able to get my point? Drop a quick yes or no in the chat, guys. ठीक लग रहा है? चलो. तो अब क्योंकि हम लोग इसको DFS से कर रहे हैं, because we are using it using DFS, we need to write a recursive code. And if you have not seen my recursion video, then I would like to give you a reminder or maybe just a revision for that. That whenever you are writing a recursive code, you just need to think of three things. Just three things, nothing more than that. One is the base case. Next is the recursive intuition. What was the last one? Self work. Are you guys able to get this point? That these are the three things that you need to maintain in a recursive code. If you are able to figure out these three things, the problem will be cakewalk, right? The problem will be cakewalk. Are you guys able to understand my point? Okay. So now what I will say is, if I have found the first occurrence where I can find the A, and now I need to search for the rest of the string, what I will say? What I will say? Gaurav, we will discuss a variation around that later maybe. So what we can say is, let's think of the recursive intuition first. What will be the recursive intuition? That let's say we were able to find our string from the right, or maybe from the down, or maybe from the left, or maybe from the up. From any one of the directions, if I'm able to find my string, then I will say what will be my self work? My self work will be returned true. Why? Because I was able to find the whole string. But there is a catch. There is a catch. Let us see. So let's say you search for A. A will make 4 calls: up, down, left, right. And let's say it came to B. Now B will also make 4 calls: up, right, down, and left again. Are you guys able to see this? Are you guys able to see this? That B is going to call A. Then our code will come to A again. A will call B. Then B will call A. A will call B. B will call A. So on and so forth. This can lead to infinite recursion. Vikram, I'll reveal that as well. We have planned for next 2 weeks, right? Okay. So few people are saying we can just maintain a visited array, just like how we do in rat in a maze problem. But I will say you don't even need this. You don't even need a visited array. What you can do, from whatever parent you are coming after making the recursive call, let's just update the character of the parent to be, let's say, dollar. Right. Now, if A will search for B, then let's say the next word was A, B, A. So B will come here back. We will check, okay, this is now dollar. We don't have to recurse from here, and this call will be nullified. Are you guys able to get my point? Are you guys able to get my point? Right. You don't need to maintain a visited array because it will take n square extra space. We won't afford that. Right. But we can just update the current character of the cell. But now there will be another issue. Let's just see what. Let's just see what. So this is A B C E S F C S, A B C E S F C S, A D E E. Okay. So now let's just try to dry run our algorithm on this particular test case. No, Shivang, I don't think that. Okay. So what are the two occurrences? Can I say these are the two occurrences of A, which is the first character of the string? Yes or no? Yes or no, guys? Okay. Let's say this was BC. Let's say this was also BC, right? Yes, Sushil, you are on the right track. Now let's say we started from this A. We started from this A. From this A, we can make 4 calls, either to upwards, rightwards. Can we make a downwards call? No. Can we make a leftward call? No. So we'll make 2 calls only. Let's say we came to this cell. We came to this B. Now before coming to this B, what I'll do, I'll update this A with dollar. I will update this A with dollar so that B will never call to this dollar. Right. Okay. Now B will explore its neighbor. Above we have A, we won't make a call. Leftwards we can never make a call. Downwards we have a dollar. I won't make a call. I will make a call to the right. And rightwards is C. Okay. And we were supposed to find what? A, B, C, C, E, D. Okay. Makes sense. Now let's say from this C, we will again make 4 calls. But before doing that, I will just update B to be dollar again. Fair enough. Now we are at this C. What are the 4 directions? Above, downwards, rightward, leftward. Can we make a call to the leftward? You guys tell me. Can we make the call to the leftward? No, because it is already updated with dollar. Now you have only 4 choices: upwards, downwards, or rightwards. Upwards we cannot go. Why? Because it is B and we want a C. Downwards we cannot go because it is D. We want a C. Rightwards we can go. And before going to rightwards, I'll update this to dollar as well. And we have arrived at this C, right? Now from this C, now from this C, uh, let's say here maybe we can have uh, instead of this E, let's say we have an S, right? Instead of this E, we have an S. Okay. Now from this C again, one, two, three calls. Next character is C, but expected is what? E. On the right words, next character is S, expected is E. Next character is S, expected is E. Now this is a point. This is a point where we were not able to recurse further. Are you guys able to get my point? We are not able to recurse further. Is this point making sense? Now, what we will do, we will just return back from here. We'll just return back from here. Right. Now we have come to this. Now, here you can see that you updated this character C. Right. You updated this character C. And let's say instead of this D also, we had a letter like C. Now, you made a call to the rightwards, but your call to the downwards is still left. But would you be able to make it? No. Why? Because you have a dollar here. You need to remove this dollar. You need to remove this dollar and make C to its original state first. Are you guys able to get my point? And this step of adding and removing of dollar will be the backtracking step or the pruning step. Pruning step was this, and this will be the backtracking step. So we can just apply simple DFS, or I can say recursion, in order to solve this problem. Now, in order to solve this problem, we don't need to make a graph. No need to make a graph. Right? We don't even need to make a graph. Are you guys able to get my point? And we just want to search for a word in a grid. We can just do directly using DFS, which is a graph algorithm. Are you guys able to get my point? So Akash is saying backtracking step again. Okay, Akash, let's see. So let's say this was a C here, this was an S here, and let's say this was a C here, and we know this can never give you a right answer, and you updated this to dollar, right? So what we'll do, you will just return back to this state. Now let's say you made a call to above was B, no issues. You made a call to right and explored all possible paths, but this can never give you a right answer. So your downwards is left. If you'll just directly make a call to downwards, what will happen? If you'll just directly make a call to downwards, what will happen? This is still dollar. This is still dollar. And this change was made when we made from this to right. And let's say you will say that, okay, what issue do we have? Okay, let's say we don't have any issue currently, right? From C, you will go to S. From this S, you can't go right, you can't go left. You will just come back and algorithm stopped. Now we have explored all the possible paths from this A, but we are still left with all the possible paths from this A, right? And because when we were exploring using this A, we changed a lot of characters to dollar, we might not get our final answer using this search. Why? Because this can use this C as the answer, but we have replaced it with a dollar. So this changing of character will make a lot of issues in the backtracking step. And this is the step of backtracking. So we need to re-update it to the original value. Are you guys able to get my point? No, Shivang, that's totally a wrong complexity, I would say. Definitely a wrong complexity. Ishani, that's a very, very nice question. So Ishani says that, okay, let's say we updated it to dollar. Now, after coming back, how we will realize it? So this will help with, we will get a help from call stack. Why? Whenever you make a recursive call, you add a new stack frame. Yes, Shivang, I'll explain, don't worry. I'll explain, don't worry. So you add a stack frame. Now, if any call cannot be made further from this C, you will come back to the same character, to the same cell, right? On the previous stack frame. And you will have the access on the previous stack frame. Are you able to get my point? Right? Cool. So we'll implement this. But first of all, there is a very good doubt from Shivang. What will be the space complexity? What will be the space complexity of the solution? Bhaiya, so guys, one very small request that I have. Please have good usernames whenever you are coming to, I would say, a learning class, right? This is not a normal YouTube stream. I won't even take the doubts of those people who have these kind of funny names because I can't pronounce them. I don't want to shatter the whole concentration of the class, right? Please have good usernames before you join. Just that's just a suggestion, a generous suggestion from your instructor. If you want, you can just take that. Otherwise, you can avoid it. But just a suggestion. Cool. So, what will be the space complexity? Here you can see that we have not taken any extra grid or anything. So seems like the space complexity is constant, but it is not constant. It will be big O of length of the search word. It will be big O of length of the search word. Why? Why it will be that? Few people will say that, okay, in worst case, what will happen? We will be going to every cell of the grid using recursion. But that will not happen. That will not happen. Why? Because if at any point of time you need to make more than string dot length recursion calls, then you obviously know that you have not found your corresponding string. You won't make a call. Mayur, it is not constant, definitely. Right. Shivang, but you can't directly say that, right? You can't just take any, you can't just map all the constraints into one, right? You can't just map all the constraints into one. If so, Shivang is saying that if the length of the word is equals to n square, maybe, then the complexity will be big O of n square. Then I don't think we don't even need to make this much recursive logic, right? We will first only check that okay, all the characters are present or not, and then we will make a recursive call. Then the logic will also change, right? So the complexity will be length of word, space complexity, and this is coming from the call stack. This is coming from the call stack. Why? Because we will be making these many recursive calls. If we ever had to make more than the length of word size recursive calls, then obviously we have not found our string and we will just return back. Are you guys able to get my point? Yes. So Rajat has asked a doubt that do we count space, stack space and space complexity? Yes, Rajat. Anything that grows gradually based on your input size, that space you have to consider anyhow. Does that make sense? Uh, Savant, do you know how stack frame works for recursive calls and function calls? I guess if you don't know, then yeah. So what's your doubt exactly? Yes, let's say you made a call from A to B, then you made a call from B to C, you made a call from C to D, and then let's say you made a call from D to E, and then you made a call from E to F, then F to G, and then from again G to B. If you'll not update it, then this cycle will go on, right? Okay, so we will code it, Savant, and then you will be able to realize it. But before coding it, what will be the time complexity? I am 99% sure that most of the people won't be able to give the tightest possible bound. Guys, give me the tightest possible bound of this problem. Give me the tightest possible bound. Ishani says n square. This is very, very loose bound, Ishani. And I guess this is not even correct. This is not even correct, Ishani, I would say. Learner, this is very loose bound. Manish, I guess this is incorrect. Rahul, this is incorrect if you are considering n as one dimension. No, Rajat, this won't be the case. Ishani, yes, but then you are making recursive calls also, no? So let's say you got n square minus 2 occurrences or n square minus 3 occurrences of the first letter. Then from every such letter you will be making recursive calls, right? You didn't consider that. Okay. So let's just observe our algorithm. So what our algorithm will say, first go one by one to all the characters and check if we were able to found the first character or not. Yes or no? So at least we need how much time? At least we need n square time. At least. But there is something more than that. Now, from as soon as you have found the first character, as soon as you have found the first character, let's say, or this first character, now you will be making recursive calls on four directions. Yes or no? You will be making recursive calls in four directions. Does that make sense? Guys, is this point clear that from every cell you will make calls in all four directions? How many cells are there? N square cells. And from each cell you have four choices, either to go up or down or left or right. So can I say, if you have n square cells and for each cell you have four choices, then you will be having 4 raised to the power n square choices. Are you able to get my point? Right. Let's say you had four elements, 1, 2, 3, 4. Right. This has two choices. This element has two choices. This element has two choices. This element has two choices. So overall choices are what? 2 raised to the power 4. Similarly, every element has three choices. Sorry, four choices. And there are n square such cells. So 4 raised to the power n square. Big O of n square into 4 raised to the power n square. Does this point make sense? Yes, Rajat, I'm coming to that. But this is very loose. This is very, very loose bound. Are you guys able to see this point? This is very, very, very loose bound. How? Okay. So now let's say we came to this C from the above C. Now at this C, we only have three choices, left, right, down. We cannot go upward. Why? Because the cell from which we are coming, we won't be going to that cell again and recurse for everything again. So instead of saying four choices, actually we just have three choices only. Why? Because one choice was cancelled due to the parent. Are you guys able to get this point? So instead of writing it as 4 raised to the power n square, I will say 3 raised to the power n square. Yes, this n square is multiplied because you need to search first character, right? This is coming for that. And after searching for all occurrences of first character, you are going to make 3 raised to the power n square. Again, this is a loose bound. Again, this is a loose bound. Why? Anyone? This is a very, very loose bound again. Yes, it is not necessary to visit all the elements, right? We don't need to visit all the n square elements. Why? Because if we are not able to find it within the length of the string limits, we won't be able to find it further. So instead of saying n square, we should write it as 3 raised to the power L. This is the tightest complexity. This is the tightest bound. Are you guys able to understand this point? Drop a quick yes or no in the chat. We will start the implementation. Are you guys finding this problem interesting enough? The implementation is going to be really, really easy, I would say. And after this problem, we are going to discuss a problem which was asked to me in one of the interviews that I gave for Dunzo. Right, we are going to discuss one graph problems from that. So stay tuned for that. But first, let's just implement this solution, that is word search dot cpp. Let's just bring my competitive template, right? Okay. So we are going to implement a function bool find, right? We are going to implement a function bool find. Manish, which part? Also, Aman, can you just quickly take Manish's doubt so that we can just move forward with the implementation? Okay. So bool find. So what will the parameters? First, we will have the grid of characters. So can I say char star star grid? We will have a grid of characters, yes or no? And then we will be having a search string word, right? Search string word. This will be the case. Okay. Now first we need to find the cells having first letter of the word so that we can apply DFS, right? It is not exactly coming from graphs. It is not exactly coming from graphs, but the DFS algorithm is directly applied here. So that's why I've included it in graph algorithms only. So now what we will do, we'll do for int I equals to 0, I less than, we need to also pass the grid size, let's say int n, I less than n, I plus plus, or we can just drop my favorite loop. Loop I 0 to n minus 1, loop j 0 to n minus 1. Those people who don't know why I'm writing this as a loop, I have already defined a macro for loop, which is a for loop only. And now we will try to check if grid at ij is double equal to word at 0, right? These will be the cases where we'll be finding the first word, right? Are you guys able to understand this part? We are just looping over the whole grid and finding the first character. Does that make sense? Okay. So let's say as soon as we have found the first character inside any of the cells, now we are going to recurse, right? We will write a function bool recurse and again pass char star star grid string word int n, which will be the dimensions of the grid, and I will pass int I that will help us to iterate over the corresponding string word. Does that make sense? Right. Okay. Now let's just try to write the recursive logic. So in the recursive logic, first we will do what? Let's just write the recursive intuition. What should be the recursive? What was the recursive intuition, guys? I've already told you. Tell me. What was the recursive intuition here? What was the recursive intuition here, guys? We need to make 4 calls, right? We need to make 4 calls. Are you guys able to get my point? So in order to make such calls, we also need to pass int row and int column. Why? From what row to what column we are going to move, we need to keep a track of that, right? So from every cell, we will just make 4 calls. Yes or no? We will just make 4 calls. So let's say bool retval equals to false. And now we'll make 4 calls. Retval is equals to go and recurse for the corresponding grid with the corresponding word of size, grid of size n square. And now index will be what? I plus 1. Can I say that? Why? Because we have we are assuming that we have found the first corresponding word and we are going to get the next word. And let's say we are making a call for going upwards. So from current row and current column, where should I go in order to make a direction of up? Can I say row minus 1 comma call? Yes or no? If you are at current r comma c cell, then you need to go above. How you will go? Column will remain same, row changes to row minus 1 and this value comes. Fair enough. right? Okay. Now again, retrieval is equals to, right? Now let's say this call gave you false. So you will check if, okay, so let's just write it in a better way. Let's just write it in a better way. Okay. So currently what we will be supposed to do, we will be writing four such calls, right? We will be writing four such calls. So instead of writing four such calls, I can just apply a loop. So so we'll just loop d0 to 3. We'll just loop four times, right? How we are going to loop, let us see. So we will make two arrays. We will just make two arrays, right? This will be rows and calls. I will show you the significance. Just give me 1 second. Okay. Now what I'm going to do, instead I would have made four calls, one for upward direction, one for downward direction, one for leftward direction, one for rightward direction. यही करते ना यार, कि एक बारी अपवर्ड के लिए कॉल करते, एक बारी डाउनवर्ड के लिए, एक बारी लेफ्टवर्ड के लिए, एक बारी राइटवर्ड के लिए. ये तो बहुत ही हैप्पजार्ड हो जाता. चार चार रिकर्सिव कॉल सबके लिए, कंडीशंस की चेक, सो ऑन एंड सो फोर्थ. तो मैं क्या कहता हूँ, एक लूप में इसको लिख लेते हैं. अब अगर लूप में लिख रहे होंगे तो सीधा रो-1 तो कर नहीं सकते. क्यों? क्योंकि अगर अपवर्ड्स जा रहे होंगे तो r-1 कॉमा सी होना चाहिए. अगर डाउनवर्ड्स जा रहे हैं तो r+1 कॉमा सी होना चाहिए. आर यू गाइस एबल टू गेट माय पॉइंट? अगर लेफ्टवर्ड जा रहे हैं तो r कॉमा c-1 होना चाहिए. अगर राइटवर्ड्स जा रहे हैं तो r कॉमा c+1 होना चाहिए. तो ये जो मैं डायरेक्शंस हैं इनको स्टोर कर लूंगा. कैसे? लेट्स सी. So if we are going upwards, then row should become +1, column should remain, sorry, row should become -1, column should be as it is 0, right? So if at any point of time, if I want to go to the upward direction, what I'll do, I will just add r plus rows of d and calls of d, right? Now if I want to go in the downward direction, I will do row +1 and call as it is. Then let's say I want to go in leftward direction, so row as it is, call -1. If I want to go to in the rightward direction, row as it is, call +1 or just directly 1. Are you guys able to see this point? What I have done here, instead of writing four calls, I just wrote a loop. I just quickly wrote a loop. And if at any point of time, if retrieval, if at any point of time retrieval becomes true, we will break the loop, right? Because this is saying what? Go and find the rest of the word in the rest of the grid. If we are able to find the rest of the word, we will just break out of the loop. We don't need to recurse any further. Yes or no? Now, before moving to the recursion, what was the backtracking step? We will first make the current character, that is grid of row comma call to maybe some character like dollar. Yes or no? And after coming back, we need to do what? We need to re-update it. Yes or no? So how we will update it? We will update it like grid of r c equals to word at I, because this was the current word, and we will just return retrieval. What will be the base case? If at any point of time the index becomes greater than or equal to word dot size, we will just return false, that we can never find any word after this. This will be one base case, guys. Yes or no? One more base case will be if at any point of time you are recursing and you just went out of the grid, like if row becomes less than 0 or call becomes less than 0 or row becomes greater than equal to n or call becomes greater than equal to n. In any of the cases, just return false. Is this point making sense? Is this code making sense, guys? Just drop a quick yes or no in the chat. Are you guys able to get this point? Now, what we'll do, we'll just call this recurse function from here. We'll just call the recurse function from here. Right. We'll do if recurse. If you are able to find any one occurrence of this string, right, you will pass the grid, then you will pass the word, you'll pass n. Initial first character will be 0, and row will be ith row, and column will be jth column. If that's the case, then from here also return true. If you are not able to find anything, just return false. And in any online test or interviews, you don't need to write the main function, you just need to write the basic logic. We have coded the basic logic. Code was really easy. Can we say that? Guys, is this point clear? Now, for all those people who face issues with recursion and backtracking logic, next week we are starting the micro course on recursion, and next to next week we are starting the micro course on backtracking. Both the courses will be uploaded by today EOD or tomorrow EOD, so you can check that out. Both of them will be free, so you guys can definitely check that out and revise your concepts of recursion. That would definitely help you to apply DFS, because this is pure DFS logic only. DFS is recursion, recursion is DFS. You can just say anything. Are you able to get my point? Depth first search is all that we need to know. Yes, yes. This part, line 63 and line 65, are the backtracking part. That is, when you are coming back, you need to re-update the state to the original situation. ओके, एक एक काफी इंपॉर्टेंट चेक रह गया. एक बेसिक सा चेक तो रह गया. ये भी तो चेक करना होगा ना कि करंट कैरेक्टर जो है वो वर्ड के करंट कैरेक्टर से मैच कर रहा है नहीं कर रहा. सो ग्रिड एट रो कॉल should be, if it is not equal to word at I, then also return false. एक बेसिक सा चेक रह गया था कि यार अगर जिस भी तुम करंट कैरेक्टर पे हो वो वर्ड के करंट कैरेक्टर से मैच नहीं करता तो भी रिटर्न फॉल्स कर दो. फेयर इनफ. Guys, is this point clear? Any doubts? Shivang, are you having any doubts? Okay, what's your doubt? So few people are facing doubt in time complexity. Tell me. Okay, so it's clear now. Cool. Fair enough. Guys, is the problem clear to you guys? This was a easy medium problem according to me. If you'll search on internet, you will find the tag as medium. And this has been asked in various companies, Google, Facebook, Bloomberg, everywhere. This problem has been asked. Few of my friends were also asked same to same, exactly ditto same problem. So do make sure that you understood the problem fairly properly, right? Manish, it is just storing the response of the recursive call, right? Boolean, true or false. Okay, so Shivang is also saying that he was asked the same problem in Microsoft as well. So as you guys can see, one of the fellow students have also faced a similar problem. So make sure that you understood the whole problem. This is one of the very important problems that I have seen till now. Yash also says he got this in one of the online tests. Naveen says he got the same problem in Adobe. So you guys can see the frequency of this problem is really high. Fair enough, guys. Shall we move to the next problem? Shall we move to the next problem? Okay. So the next problem, you won't find it very frequently, but this problem was asked to me in Dunzo. I was able to crack it. I was able to crack the whole offer. Uh, but I feel this is one of the very important problems in graph algorithms. So let's just see what it is. Rajat, depends on what profile and which company you are applying to. Sometimes direct questions are also asked, but unfortunately, in my case, I was never asked any direct questions. I'm not sure why. Okay, so let's say that you have an undirected tree of n nodes, right? Some nodes have color A, some have color B, some have color C, right? Few nodes have a color A, some have a color B, some have a color C. Does that make sense? It is guaranteed, it is sure that nodes with all colors are present, right? And not for all colors. I would say that nodes for color A and B are present. This is for sure, right? At least one node will be there with color A and at least one node will be there with color B. Find the number of edges you can remove such that removing an edge divides the tree into two components where so what you are going to do, you will be removing edges. Now by removing one edge, such that removing one edge, the tree is divided into two components, right? The tree is divided into two components where in one component only color A is or we can say where in one component no node have a color A and in one component no node have a color B, right? You have to find how many such edges are there, find the number of such edges, so that if you can remove one edge, any of those edge, you are able to divide your tree into two components where one component is such that it has no occurrence of color A and one component is such that it has no occurrence of color B. Are you guys able to get my point? Drop a yes or no in the chat. So let's say you have a tree like this. Let's say you have a tree like this. So you have three colors A, B, C. Let's say A is red, B is blue, C is black, right? Okay. Let's say you have one node here, you have one node here. Let's say you have one node here, and let's say you have two nodes here, right? And this is, let's say, 1 2 3 4 5. Now if you will remove this edge, if you will remove this edge, so what will happen? This will become one component, this will become another component, and you can see in this component there is no occurrence of color B, in this component there is no occurrence of color A. So this is a valid edge, you will add this into your count. Is there any other valid edge? Is there any other valid edge? Drop a yes or no in the chat. No. So the answer will be 1. This is a hard problem. Non-trivial kind of. Uh, this was the deciding problem, I would say, in my interview. Uh, this was the problem from the last coding round. Last problem of the last coding round, I would say. I guess. Yeah. Last problem of the last coding round. Is the problem clear to everyone? Okay, so first of all, what you should do, you should ask the constraints, right? You should ask the constraints. So the constraints are that the number of nodes can be as big as 3 into 10 raised to the power 5. Rahul, my round was a 1 hour round in which I was asked two questions, one on DP and this one on graph. So the DP one was also a harder one. That was a I would say, trivial problem. I have not never solved it, but I was able to solve both of them and code both of them as well. Fair enough, Shivang. Seems very fair enough. What about rest of the people? Think about it, guys. Take 2 minutes. Take good 2 minutes. Think of this problem. What you would have think of if you have got this problem in your interview. Take 2 minutes. Give me your approaches. This is how only you need to interact with the interviewer, right? People on YouTube, are you able to understand the problem, guys? सवाल समझ में आ रहा है सब लोगों को? ये बताओ सब लोग पहले. सब लोगों को ये सवाल समझ में आ गया है? फटाफट से ये बताओ. Drop a quick yes or no in the chat. Tourist, can you raise it on the support? Maybe. Nikita says no. Nikita, what part you are not able to understand? No, Saurabh, you have to count all such edges such that if you remove one such edge, you get two components where in one component there is no occurrence of color A and in one component there is no occurrence of color B. Think about it, guys. Only one of you guys have given the right solution. I want you to think. This is very, very crucial. I don't want to discuss lots of problem with lower quality. I want to discuss good quality problems that are relevant for interviews that maybe I have faced somewhere or are frequently asked so that I can share a lot of experience around them, how what's the thinking process, so on and so forth, right? Why the answer will be two, Karthik? What other edge you will remove in order to divide it in two components? Ha, Rajat, you are on the right track, but you need to think of just one more thing. I was stuck at that point on this one thing that you have missed, and I was able to crack it later. Okay, Savan, but how you will count all such edges using this? Yes, always, Rahul, you can assume. You can assume maybe. Savant, I'm not saying how you will count it, but how you will realize the fact that whether adding this edge will add to the global answer or not, right? Because maybe Adding one such edge currently might not make a difference, but if you will make rest of the graph, then it can make some issues, right? Your approach seems fine, but you need to have some proof checks around it, that how your approach is definitely going to be correct always. It seems fine, but any proof checks around it. Nikita, you have to count the number of edges such that if you remove any of those edge, you are able to divide the graph into two components such that one component never have any occurrence of color B and one component never has a occurrence of color A. Yes, do you think you will get the right answer using this? No रजत, I don't think so. मतलब वो तो डीएफएस में वो तो वैसे ही रिक्वायर्ड होता है ना. वेस्टेड अगर डीएफएस लगाओगे तो वही होगा. तो कुछ और मिस कर रहे हो. I don't think tourist you need to think that hard. Fairly simple. This is fairly simple. Interview problems are not going to be like very tough competitive problem, but they can be non-traditional. इसका सॉल्यूशन बताऊंगा तो बिल्कुल ऐसा लगेगा कि अरे यार क्या ही सोचना था, कहाँ कहाँ पहुंच रहे थे. No Rahul, I don't think you need to update any value. Anyone else with any hints? So we'll just start the discussion in 2 minutes, guys. We just have 2 more minutes. Tell me what could be a valid solution for this, and then we will start. Utkarsh, the problem is you are given a tree which can have three kind of colors: A, B, and C. Right now, you can assume that at least one node will be having a color A and one node will be having a color B. You can assume this. Now you have to find the number of edges such that on removal of one such edge divides the tree into two components. मतलब ऐसे कुछ कुछ edges हैं जिनको remove करने से ट्री को दो कंपोनेंट में डिवाइड कर सकते हो सच दैट एक कंपोनेंट में कभी भी कोई कलर ए नहीं होगा, एक कंपोनेंट में कभी कलर बी नहीं होगा. ऐसी कितनी एजेस हैं जिनको डिवाइड करने से ऐसे कंपोनेंट बनते हैं? यू हैव टू काउंट ऑल सच एजेस. डज दैट मेक सेंस? थिंक अबाउट इट गाइस. Soham says assigning 1 to 1 and 0 to red and blue and check subtree sum for every node. Soham, you're on the right track probably. Let me check Ishani's approach. If I start from A leaving B. Not exactly, Ishani. I don't think this might work. Guys, shall we start? Everyone on YouTube as well as on Unacademy. Shall we start? Okay, fair enough. Okay. So what you want to do is remove any such edge such that it can divide your tree into two different components. Now we know that being a tree, if you will remove any edge, it will divide it into two components. That's for sure because it already has n minus 1 edges. Fair enough? Right. Okay. Now we have to find all the valid edges and count the all the valid edges. Now, what will happen with the valid edge? If you will remove a valid edge, then let's say this is component 1, C1. This is component 2, C2. Can I say component 1 dot red, that is the count of red nodes in component 1 will be equal to original red nodes, original red count? Can I say that? Can I say that? Guys, drop a yes or no in the chat. And component 2 dot blue will be equal to count of blue nodes. Yes or no? So what we can do, we can one by one come to different nodes, right? And let's say from each node we will be doing a DFS. We'll just do a DFS. Now what will happen is, let's say from 2 you went to 3. So what you are doing, you are going to the subtree of 3. You need to do two things: count red nodes and count blue nodes. Are you guys able to get this point? If at any point of time your subtree at which you are going, the count of red becomes equal to the original count of red and count of blue becomes 0, then obviously you can say this is a valid edge, you can remove it. But currently here you can see this is not a valid edge because count of red is also 0, count of blue is also 0 because this is a black edge. Now let's say you removed this edge and you will make a DFS to this subtree. Now the count of red will become 1, the count of blue will become 0. And here you can see that if we will just remove this particular edge, we will divide it into two components, this one and this one. So we can say just do the DFS one by one. And for any subtree or subgraph that you are going, just keep a count of the number of red nodes you have found and the number of blue nodes you have found. And if the found number is equal to the original ones, right? That is, let's say you found all the red nodes and you found 0 blue nodes, because there can be a case that let's say you found all the red nodes, but you also found one blue node. Then obviously you can't remove this. This is supposed to be there, right? But if you found all the red nodes, but you found no blue nodes, then obviously this is a special edge, you can remove it. And you will just do count plus equal to 1. Are you able to get this point? Tourist says that the time complexity will not be too high. No tourist, because we are not going to do DFS from every edge. We will just do one DFS. Start from any one node and do the DFS. While doing DFS, you will do what? You will traverse all the edges at least. Anyhow, you are going to traverse all the edges, right? Rajat says, are we given the count of red and blue? Rajat, you will be given the graph. So when creating a graph, can't you just keep a count? Yes, Shivang says, what is the relevance of C nodes? So Shivang, the relevance of C nodes is to just to increase the complexity of the problem. Why? Because in one component here you can see you have both blue and black color nodes. So the black color nodes can be present in any of the component. There is no restriction on that, right? It is just to improve the complexity of the problem to just confuse the candidate. Otherwise, you just need to focus on red and blue nodes. Learners say, please dry run it. Okay, we can definitely dry run this. Uh, let's just keep it with this color. Right, okay. So this is, let's say, a red node. This is a blue node. And this is a black node. Let's say this is A, B, C, D, E. Okay, from what node should I start the DFS? Let's just start from A. Okay, we know the count of red is equals to 1 and count of blue is equals to 2. Right, okay. I will go. What is color B? Color B is blue. I will go to the subtree of A, right, and get a count. So if you are going to the subtree of A, you will come to what? You will come to B. Okay, now you are at B. From B, you will go to the subtrees of B. You can't go back to A, obviously. So from B, you can go to C, E, and D. Okay, so let's say from B, you go to E. Now you are at E, base case. Now you are at E, base case. Now this is what? This can never go further. So you will just return a count blue. That, okay, I have a blue node, one blue node. So this subtree of B found one blue node and zero red nodes. So we cannot remove this edge. Why? Because neither we have found all blues, neither we have found all red. Now from this B, we will make a call to this. This is again a base case. We'll just return one red, zero blue. And here you can see that we have found at least one complete color. So we can definitely say that this edge can be removed. Are you able to get this point? Right. Okay. Now this will give you a color black. So what will B return to A? B will return one red, one blue, one black. So can we remove this edge of A? No. Why? Because we have never found all reds in the component of or in the subtree of A. Neither we have found all blues in the component of A. So we cannot remove it. So we'll just remove this edge and the answer will be 1. Is this point clear? Akash, you can start from any node. Instead of A, start from D. Or maybe start from C. The answer will remain same. Yuvraj, it will be starting soon. It will be starting soon. There are some caveats around it, but it will be starting soon. Fair enough. Guys, is the approach clear to everyone? Everyone on YouTube as well as on Unacademy? Is the problem clear to you guys? Drop a quick yes or no in the chat. Saravanan, can you try this on your own maybe? Do you think that will make a difference? Okay, so let's just start to code it. Let's just see how we can code it. So we can just say this is like edge cutting dot cpp cpp. Cool. Okay, so first we are going to do what? We will just, when we are taking the input of the graph, we will just count red and blues at that point of time only. So we will be given n nodes, C in n. Fair enough, right? So if, and we are already given that this is an undirected tree. So do we need the number of edges? No. The number of edges will be equal to what? N minus 1. So we'll loop from I 0 to n minus 1. Yes or no, guys? And this will be n minus 2 in my case because, oh no, n minus. So let's just start from 1 to n minus 1. Make sense? Guys, is this point making sense? Being a tree, it will be having n minus 1 edges. Now we are going to take the input of the edge. Drop a yes or no, guys. Drop a yes or no. Right, okay. Now we can just make an adjacency list. We can just make an adjacency list. So let's just make a global adjacency list. So we can just do list of integers, right? We can just do list of integer, and this will be having an array. So let's say graph, and let's say of size. Okay, maybe instead of making global, we can just make it local of size n. Fair enough, guys. Is this point making sense? This will act as an adjacency list now, right? Okay. So we'll keep a count of red also. Count red equals to currently 0. Count blue equals to currently 0. Fair enough, right? Initially, what we will get, we will first get the colors of all the nodes. So for all the nodes are loop I 0 to n minus 1. We will first check colors of all the nodes. We will be first given the color of all the nodes. So int color, scene color, right? If let's say this is char color, if color double equal to a, right, we'll say count red plus equal to 1, right? And if color equal to b, count blue plus equal to 1. Fair enough, guys. We will be first given the color because we have been given the whole configuration of the graph. So we will be given the color first. Now we will be given the edges. So edge will be from u to v, int u to v, right? So we'll do c in uv, right? And you can just make it one based now, but we have a graph like this, just let it make sense to make it zero based. So you can do u is equals to, or we can just do graph of u minus 1 dot pushback. Pb is pushback. Here you can see pb is defined as pushback. This will be v minus 1, and similarly graph of v minus 1 dot pushback u minus 1. Are you able to see the undirected tree that we have made? We have made the whole tree. Does that make sense? Obviously, Naveen, how I am able to see the chart then? Guys, does this seems fair enough? Right, cool. Okay, now we just need to do what? We just need to do DFS, right? We just need to do DFS. Now inside DFS, we'll just keep a pair, right? Pair of, we can keep a long int. So PII, why PII? Because I've already defined PII. If you are given it in an online test, you might not have this template, so you need to write something like pair of long int, or maybe pair of int comma int. But I have the template, so I don't want to waste time. So PII will write a DFS. Now we'll be given an int source. The source, any source node that you need to give, you can just do that, and you will be given a parent, right? Parent. So currently the parent of the source will be -1. Fair enough, guys. Is this point making sense? Drop a yes or no in the chat. We need to also pass the graph, guys. Do we need to also pass the graph? Yes or no? So easier way to make this graph global, and even make this integer n also global, right? This will help us to keep things on that part. And maybe we can just make a graph of very big value of, let's say, something like 10 raised to the power 5 maybe, right? We can just make it global. I just don't want to pass it somewhere around here and there. Cool, fair enough. Gaurav says why pair required, because pair will return the count of blue and the count of red in my subtree, The count of blue and the count of red in my subtree. Fair enough? Right. Okay. Now you want to do the DFS. How you can do the DFS? So for auto neighbor in graph at source, we'll go to all the neighbors. Yes or no? And you will check if neighbor is not equal to parent, then only you are going to make a call. Fair enough? Okay. Now you will get a result is equals to DFS of neighbor. You will go and calculate what are the, by using DFS, what are the number of reds and the number of blue in the subtree of neighbor. Does that make sense? Now, what you can do is you can pass an answer variable. You can make int answer equals to 0. And this will be parent. You can pass int answer. Right? Or you can just make it global as well. No issues. And make it answer equal to 0 here. Cool. Okay. Now what we'll do, we'll just check answer plus equal to. We will see if result dot ff means first. I've already defined ff as first and ss as second. So let's say if we have all the nodes of color red, right, and there was no node of color blue, can I say I will add 1 to my answer that I have found one such edge? And the same thing I will do for color blue. Fair enough? Guys, is this point making sense? So instead you can just make this, okay, this is count red here. So let's just make it count red and count blue. And you can just initialize count red and count blue here. Right? Anything else that you need to do? Anything else that you need to do? Now, you have just checked that whether this edge was coming in the valid answer or not. But you have to return something to your parent as well. So you will return what was the total number of reds and blue. Right? What was the total number of reds and blue? So you will first check if the source node is red or not. So you will check if the current source node, right? So how you will check the source node? How will check for the source node? Anyone? How you can check for the source node? So we can just store the color of all the nodes in an array. So int colors. This is also going to be of, let's say, size n. And when we are having this color, I will do colors at I equal to color. Fair enough? Right. Now we also have the access to all the colors of any node. So I'll just check if colors at I is double equal to A, right? Then I will just store this in red, and blue will also be the same. Colors at I double equal to B. Fair enough. And this will be char colors. No, Soham, this will be checked if you have all the nodes red, no nodes blue. This will be checked when you have all the nodes blue, no node red. So either this will add 1 or this will add 1, right? Okay. Now what are the number of reds? Red is equals to result.ff. What are the number of blues? Result.ff. And this is coming from all the neighbors. So you will just return what? You will return your parent, the number of reds and the number of blue. And done. This DFS implementation has been done. You can just call DFS of 0 and you can just do cout answer. Fair enough? Is this point making sense? Why this line should not be in for loop? Any specific criteria for that? We are going to all the neighbors of the current node. If you want to go to all the neighbors of the current node, how you will go without a for loop? Okay, this is result.ss. Thanks, tourist. Naveen, you can find that on my GitHub. Guys, does this seems fair enough? Does the code seems fair enough? I know the logic is a bit complex. That is, you are going to do DFS, you will return pair, you will check if the edge is correct or not. You also want to return something to your parent, that is the number of red in your subtree and the number of blue in your subtree. But the code is pretty short. The code is pretty short if you have already made the graph. Is the logic clear to everyone? Fair enough? Anyone having any doubts? Anyone having any kind of doubts? Just drop a yes or no in the chat. Line number 61. Why this should be in for loop, Sachin? This should not be in for loop because this is doing currently for the source node. What is the color of the source node? Right? Whatever the color of the source node, that should also be added for your parent, right? Because you are returning to your parent. Parent should also get, and here you will only add for neighbors of the source node. The parent should also get colors from all the neighbors and the source node as well. Fair enough? Okay, so those people who want a link for my template, let me just share it with you guys. Just give me 1 second if you want it. Just 1 second. So I have a Sublime file probably somewhere. Let me check. I shared it to someone, I guess. Okay, yeah. So I have a Sublime snippet file. You can copy it in Sublime so that you can just do that. I have shared the link in the chat, both on Academy as well as on YouTube. This is the template that I use while doing competitive programming. So you can just check this out. These are a few cool functions like loop and log ARR. So log helps me to log a lot of things. So I can just write log n comma answer comma anything. So it will just print everything. You don't need to write cout for it every individual variable. I just directly use log. You guys can definitely check this out, explore it on your own. You need to have good knowledge of C++ to understand it, but if you are able to get a hang of it, it will be very beneficial in competitive, I would say. Gaurav says we can implement it using adjacency matrix or not. You guys tell me. I have given you the constraints as well. Can you guys implement this using adjacency matrix? No. Why? Because the number of nodes can be as big as 3 into 10 raised per 5. If you will be implementing it using a matrix, it will be 10 raised per 10 something, and you cannot make a 2D array of that big size. Fair enough? Does that make sense? Tourist, if you are making that using new or delete, right, that is the new syntax, you can just pass it like this, right? Syntax you can Google, no issues. Guys, shall we move to the next problem? Guys, did you find this problem interesting enough? This was asked to me in Dunzo. I also really found this problem to be really good. Interviewer was also very impressed when I proposed the solution to him. Although initially I fumbled a bit, but I was able to crack few things around it. So, did you also found this problem interesting enough? No, Naveen. Cool. So, guys, this interview series that we are running, we just want that for all those people who are preparing for interviews, you guys can get benefits out of it. So, make sure that you also share as much as possible with your peer group so that everyone can watch it, right? Cool. Next problem I'm going to take is going to be fairly easy and traditional, right? Because every time on not only tough problems are asked, but also traditional problems are asked. Okay, so let's just see what's the problem. So let's say you are given a graph. Let's say you are given a graph, right? Find if the graph contains cycle or not. Let's say this is a graph. So here we have a cycle, so you will just return true. You need to detect if your graph has cycle or not. How you guys can solve it? Think about it. Though I guess a lot of people might have already done this. I have also taught it using one approach. I will be teaching another approach today. Fast and slow pointer. Rajat, how you will iterate on graph using fast and slow? I guess I'm not aware. This is not a linked list. It's a graph. Okay, so Shekhar Motian, I'm really sorry I missed your message. I guess that were coming in question section. Uh, yes, I guess your approach was also correct. Okay, Sachin. Guys, drop the algorithm as well. That how you will use that algorithm. Drop the whole process. Soham, I guess you are thinking too far. Fair enough, Shivang. We'll do much simple things than this, but seems fair enough. Uh, Pratap, you are on the right track, bro. Yes, Manish. Let's say the number of nodes can be as big as 10 raised per 5, and the number of edges can also be as big as 10 raised per 5. Guys, how you will find a cycle in the graph? This so we have discussed three different type of problems today. This is the third one. One we discussed, which was very rarely asked, but is one of the tough ones and can be asked in those companies which aim to target tougher level problems. One we have seen that is not a traditional problem, but has been asked in lots and lots of companies very frequently. This one is a traditional problems, one of the traditional problem of graph, core algorithm of the graph, and this is also asked in lots and lot of companies because it has a lot of applications in advanced graph algorithm. So think about it, how you can solve it. Akash, I don't think this is the right approach. You need to improvise it a bit. Tourist, I guess you need to improvise it a bit. Rahul, how you can do it without updating any symbol and without any using any visited array? Utkarsh, you're on the right track. Ashwini, fair enough, but we will do something more simple, but you are also on the right track. Guys, if at any point of time I'm not able to read your message, really very sorry. Sometime it happens that multiple messages gets popped up. So I might miss your message, but I try to answer as much as possible. Gaurav says my approach. Uh, why you need two arrays, Gaurav? Why you even need an array? Maybe you can do it without it. Uh, Ashutosh, don't you think it is not a tree? So the count of the edges doesn't even matter, no? You can have, in a dense graph, you can have n square edges. How come n minus 1 makes any sense? Okay, I got your point. I got your point. If edge we have is greater than n minus 1. Okay, so you are trying to count the number of edges so that it becomes equal to tree or something. Is this something that you are trying to do? Ashutosh, you just want to count the number of edges so that you can check if it is within the limits of tree or not. Is this your approach? If I can summarize. I guess first of all, first thing that I can directly think of is you are doing too much uh, running, because if let's say you have a cycle present, then you can detect it much earlier rather than counting it the whole number of edges. And I'm thinking if this approach will even work or not. Counting the edges, will that work? Yes. How about disconnected components maybe? But let's say if we have just one component, will that work in one component? I'm thinking. Self, yeah, so you need to do a lot of checks of self loops, so on and so forth. Yes, Aman, that will be the case when you'll be having multiple components. But let's say if we just have one component only, uh, I guess then this approach will work. But you need to have a lot of cases for self loops and all everything. So I don't think this should be the most optimal one, because although it misses a lot of cases also, but yeah. Okay, shall we start the discussion, guys? The problem is fairly simple. The problem is fairly simple. Don't need to think a lot on it. Let's just make a graph quickly. Right. Okay. So from any point of node, from any node, just do a depth first search. Just do a DFS. Right. So let's say from A, you can keep the track of the node and you can keep the track of the parent. So the parent of A is minus 1. Let's say you made a call to C. So you went to C comma A. Now the parent of C is A. Right. So every time you just need to check that whether the node that you are going to is already visited or not. So you can just keep a visited kind of a thing. Right. Then from C, you will go to E. Right. So we will go to E comma C. Fair enough. Right. Now from E, you can maybe go to C, but C is already visited. You can't go there. So from E, you will go to G. So it will be G comma E. From G, you will go to F. F comma G. G is the parent. Second parameter is the parent. You need to keep the track of the parent. Now from F, you can't go to G back because it is already visited. If you will go to E, if you will go to E, then can you see that this E has already been visited? Are you able to get this point? This E was already visited. right? But just keeping a check of visited won't work. Why? Because this G was also visited, but this at this point of time we didn't have a cycle. So when we will get a cycle, if the node is already visited and is not my parent, G was the parent of F and G was also visited. So we know that G was the source from which we came to F. But that's not the case with E. In the case of E, we are coming from F to E. E was already visited, right? But E was not the parent of F, just like G. So here we can say that we have detected a cycle. Fair enough. Is this point making sense? So you can just do a DFS. Just do a DFS, keeping a track of parent and visited nodes. Because visited nodes you already kept while doing DFS. You just need to do one more thing of keeping a track of my parent, right? Now, if you found a visited node which is not the parent of current node, you found a cycle. Are you guys able to get this point? Rahul says one more time. Okay. So let's say from A you went to, right? Okay. Let's just start from A. Who is the parent of A? Can I say currently no one is parent of A? So parent of A is, let's say, any symbol, -1. Now from A, you can go to any node. Let's just say you went to B. So B comma A. Now you can never go from anything from B. You will come back to A and you will go to C, right? And in visited, you have A as visited and B as visited. Now you went to C. Who is the parent of C? A is the parent of C. So C is also visited. Now from C, you went to E. Who is the parent of E? C is the parent of E. And now E is also visited. From E, you went to G. Who is the parent of G? E is the parent of G. Right. Now from G, let's say you made a call to E again. Now E was the source from which G was extracted. So E was the parent of G. So we can say if you found any node which was already visited and was my parent, so you will do nothing. You will do nothing, move forward, just avoid this node. Now from G you went to F. So F comma G. G is the parent of F. Now from F again, when let's say you made a call to G. G was the parent of F and G was also visited already. This doesn't make sense because this is not a cycle. This is just the parent node. So we'll just move forward and we'll mark F as visited. Now from F you went to E. Now from F you went to E. So here you can see that. Here you can see that E is already visited. E is already visited and E is not the parent of F. So can you say we have detected a cycle? Are you guys able to get this point? Rahul and Gaurav. At any point of time, if you are able to get a node which is already vested and not my parent. Why? What's the intuition behind it? Because in normal DFS, when you made a call to your parent, it was stored in visited. And in a cycle, we will get a node in a cycle when it is already visited. So how you will distinguish between a cyclic node and a parent node? So you can just keep a track of the parent to distinguish it from the node creating the cycle. Is this point making sense? Guys, are you guys able to understand this? Drop a quick yes or no in the chat. Everyone on YouTube as well as on Unacademy, are you finding this simple enough? This was one of the traditional problems and one of the traditional algorithms from graphs, and it is also very, very frequently asked in interviews. Does that make sense? Cool. Any kind of doubts, guys? Any doubts? Anyone having any doubts? Let me share you the notes. Let me just quickly share the notes. If anyone has any doubt, you can definitely ask me, guys. Uh, Let me quickly upload the notes. People on YouTube, guys, do you have any doubt? Savant, you can maybe Google about it. I don't currently have the link. Saurabh, yes, because they work on bit level, right? Ashutosh, you won't be able to say it in case of disconnected, like disconnected graph, right? Which has multiple components. Because for DFS, right? Make sense? Okay, so I'm uploading the file, guys. Just give me 1 minute. Guys, any doubts from the previous two problems as well? You can just quickly ask me. Yes, Ashutosh, like your solution has a lot of assumptions that it should not have back edge or self loop, so on and so forth. If these conditions are satisfied, then it makes sense, right? And it also like work in case of undirected graph, I guess, because directed graph also it won't be true. Do you think that makes sense? So your solution is taking a lot of assumptions. I don't think in interviews, if you will give these many assumptions, they will accept it probably. Okay, so guys, I've pinned the link in the chat for the notes. Just 1 second. Both on Unacademy as well as on YouTube. So you guys can check out the notes here if you want to refer the lecture once again. Does that make sense? Tourist, what do you mean by undirected nodes? Like, what do you mean by that? I don't think that even makes a sense, right? Cool. So guys, few announcements, few announcements. Next week also we are coming up with a new micro course on recursion. I'll be taking 3 classes on recursion, starting from basics. First class will be basic recursion. Second class will be intermediate recursion. Third class will be advanced recursion. After this week, after next to a week, that is next to next week, we'll be having a micro course on backtracking. First class beginners backtracking, second class intermediate backtracking, third class advanced backtracking. In backtracking we are going to discuss everything around n queens, n knights, rat in a maze, uh, a lot of problems, right? A lots and lots of problems of backtracking and recursion coming up ahead. So stay tuned for that. We are coming up with few more micro courses. So one micro course on game theory, I guess, is running currently. Deepak has started a micro course on binary search probably. So you guys can just take this out. All this will be some introductory courses that can give you a head start on how to move forward with things. I will keep continuing this interview series after this. That art coder series is still remaining. I have few discussions left around it, so I'll be updating you guys around the dates for it. But I'll be keeping in loop for these interview series, so just stay tuned for that. I'll be coming up with more interview related micro course, maybe sometimes on linked lists, tracks, everything, so that you guys can catch up both on competitive programming as well as your upcoming interviews. Though both those things can go parallelly altogether. Does that make sense? Tourist, I guess you should try with DFS, but we have to think about it, right? Try with DFS probably. Like I'm giving just uh, very 1 second thought kind of on this one. Fair enough. Cool. So guys, let's just wrap up. Let's just wrap up today's class. It was like awesome experience to have a discussion with you guys on graph interview problems. If you want to watch more such videos on different competitive programming algorithms and data structures, you guys can definitely check out the Unacademy's competitive programming platform. We are coming up with lots and lots of free live classes as well as the plus subscription. To unlock the free live classes, you can use the code Sanket10. Right, I can just ping the code on YouTube. Uh, the free live classes are totally free. You just need to unlock them, and you can use the code SANKET10 to unlock them, and then you will be able to watch them for free. Also, if you want to opt for the subscription, because we are coming up with batches now, we are going to run multiple batches on in multiple language. So if you want to learn maybe competitive programming with Python, competitive programming with Java, competitive programming with C++, intermediate competitive programming, interview batch, so on and so forth. Multiple batches are coming up. So you can also opt for the plus subscription. You can check out the prices and all on the Unacademy's platform. So till then, just stay tuned and we will meet in the next lecture. So thank you guys. Take care. Good night and keep coding.